This is lesson 4-2, triangle congruence by side, 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 which we abbreviate SSS, and side angle side, which is SAS. Now you don't have this top part on your notes, okay, so you're just going to listen and watch. But if we learned yesterday, if two triangles have three pairs of corresponding congruent angles and three pairs of congruent corresponding sides, then the triangles are congruent. So basically, if you know that all three corresponding angles are congruent, so F is congruent to J, G is congruent to K, H is congruent to L, and this is all color-coded so you can see what corresponds, but you can also tell by the picture. And if you know the three corresponding sides are congruent, so FG is congruent to JK, GH is congruent to KL, and everything's marked. The angles have these arc marks, and the ones that match up have the same number of arc marks, like F is congruent to J, G is congruent to K, and the sides that are congruent match up. So I have this little slash mark. FG is congruent to JK, they each have 1. FH and JL each have 3, so those are congruent. But if you know all three sides and all three angles, so if you have 6 things, then you know that triangle FGH is congruent to angle JKL. Now, as I mentioned yesterday, you don't need to prove all three sides and all three angles to prove the triangles are congruent. I'm going to show you 2 of the shortcuts today, and here they are. The first one is called the side, side, side postulate. So side, 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 we abbreviate SSS. So the side, side, side postulate says if 3 sides of one triangle are congruent to 3 sides of another triangle, then the 2 triangles are congruent. So basically you have all 3 sides of one triangle congruent to all 3 sides of another triangle. So again, I'll read it. If 3 sides of one triangle are congruent to 3 sides of another triangle, then the 2 triangles are congruent. And you can see I have AB is congruent to DE, BC is congruent to, oops, we lost a letter down here, BC is congruent to EF, and AC is congruent to DF. Okay, and we're going to write down the corresponding sides. So if AB is congruent to DE, BC is congruent to EF, and AC is congruent to DF. If you know all 3 sides are congruent to all 3 sides, you don't have to have the angles. The angles automatically will be congruent, so you don't have to prove them. All you have to prove are the 3 sides, so it makes it much easier to do the proof. So if we know all 3 sides, then triangle ABC is congruent to triangle DEF. And we want to be careful about the way that we write these. Remember, they have to be, the corresponding sides have to go in order. Okay, so if you need to pause the video to continue writing, you can. If you're ready, we're going to move on to the second postulate, which is the side angle side postulate. So the next one is called the side angle side postulate, SAS. Notice the angle is between the 2 sides. We say it's included. And the angle, the A right here, is included between those 2 sides. So the side angle side postulate says, if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the 2 triangles are congruent. I have 2 sides and the included angle of one triangle. So here we have triangle ABC. I have my 2 sides and the included angle. See how it's the angle between the 2 sides. It could be any 2 sides, but the angle has to be between the 2 sides. And if that's congruent to 2 sides, so here we have the 2 corresponding sides and the included angle of another triangle, then those 2 triangles will be congruent. And we're going to write out the sides that we have and the angle that we have, the included angle. So AB is congruent to DE, and I have that marked, 1 slash mark. Angle A is congruent to angle D. I have this little arc mark, one of them. And AC is congruent to DF, so I have those 2 are corresponding. They have 2 slash marks. So if I have side angle side, the 2 sides in the included angle, then my triangles are congruent. I don't have to prove the other 2 angles or the other side. So triangle ABC is congruent to triangle DEF. Okay, again, if you need to pause it, you can. Otherwise, we're just going to look at some examples, and then that's it. So my first example, I want to know, are my triangles congruent to each other? Well, let's look at what we have marked. I have two sides. That wasn't one of the postulates that we had today. We had three sides, or we had side, angle, side. But if we look a little bit more closely, is there another side that I should know? I have these two sides. Do I know anything about side LN? Well, look, these two triangles share side LN. LN is in triangle LPN, and LN is in triangle MNL. So if they share, remember that's the reflexive property. So they actually have the third side. It's not marked. That would be something that you would have to mark yourself or recognize yourself. I'm going to show you what that looks like in a little flow proof. Okay, but I know that LM and NP are congruent. That's given. It's marked on the diagram. I know that LP and NM are congruent. That's marked. And all you have to add is that third side. LN is congruent to LN, and that's the reflexive property of congruence. And I have side, angle, side. So I say that my triangle, side, side, side. So I say my triangles are congruent. Triangle LMN is congruent to triangle NPL, and the reason is side, side, side. Okay, so this is what a little flow proof looks like. So the question was, are the triangles congruent? Yes, they are congruent, and what's the reason? Side, side, side. Another type of question that we're sometimes asked are, what other information would I need to prove the triangle's congruent by a specific method and to explain? So I want to know, what other information would I need to prove these triangles congruent by side, angle, side? All I have is a side right now. Is there another side that they have congruent that I should know? Well, actually, yeah, just like this triangle, the two triangles that were up here, they share side DF. So let's make an X right here on the side that they share. So I have that second side. Now, if I have that second side DF, which I know by the reflexive property, which angle is the included angle? So I'd like you to mark it on your paper, the included angle. The included angle would be angle EFD up here. Okay, and if I have this side and this side, the included angle is down here, angle GDF. Okay, so that's what I would need. I would need DF, congruent to DF, reflexive, and then I would need angle EFD up here is congruent to angle GDF down there. And the last thing you're going to do is you're going to look at these triangles that are down here, and you're going to tell me whether you would use side, 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 or side, angle, side to prove that the triangles are congruent. If there's not enough information, which there might not be, then you write not enough information. And one of them actually has two methods, so see if you can figure that out and come in with those answers tomorrow.